Hi, I want to provide a brief tutorial on using the plot function in Mathematica. So using a PC, which is all that I have access to, you go to the Start icon in the left lower hand corner, click on it, then select All Programs, and you'll see Wolfram Mathematica, a file for that. Click on that, and you'll see the kernel and the actual program. You want to make sure you click on the actual program. And yours may or may not be 10.1. It may be more recent. But you'll have Wolfram Mathematica and the version of Mathematica that you're using. So I'm going to click on that. You'll see this opening process and then the opening screen. And you want to select a new document and a notebook. Usually what I do with the notebook is I immediately change the percentage at which I'm going to view it to 200%. And that gives a real nice visual, but you may not need to do that. And the function we want to talk about using is the plot function. All functions within Mathematica begin with a capital P, or a capital letter. So if we're going to use the plot function, this begins with a capital P. And once I type the L, a drop-down box appears with possible functions that I may be wanting to use that are defined within Mathematica. And we simply want to use the plot function. Once I click on that, there's now a double downward arrow that I can select that shows me in the first slot the most basic use of this function. And that is to put in a single function. So I'm going to put in x times x minus 3 to the third times x plus 4 to the second. So this is a polynomial function of degree 6. And I get that degree by adding the powers on these factors. So the power on the factor x is 1. The power on the factor x minus 3 is 3. The power on the factor x plus 4 is 2. So 1 plus 3 plus 2 gives me 6. So just to kind of talk a little bit about what you're learning right now, I know that this is a polynomial function of even degree. So both ends are going to rise. So in other words, it's going to rise on the left end and the right end. But putting that aside, you can use whatever letter you want. You don't have to use x. But if you are using x to define your function, then you would have to have an x here. Then you need to give a smallest value of x and a largest value of x. And so this is the most basic information that I have to give to the plot function. I have to give it a function that depends on a independent variable. In this case, that is x. And I have to give it the range that I want it to use for x. Or I shouldn't use the word range because that has a specific mathematical meaning. I have to give it a set of x values for which I want it to calculate the function. So at this point, all I need to do is hold the shift button and push enter. And then I get a graph. Now one of the things that I see right away when I see that along the y-axis, y is going from 0 to 500,000, is I know that I'm really zoomed out and I may not really be seeing clearly what's happening here because I'm so far away. So imagine that you're looking at something and you're really far away. The farther away you are, the less details you're going to see. And this is a good function to illustrate this with. So one other um, piece of information that's going to be helpful for the plot function is to give it a range over which you want to see your y values. So I'm going to go over here to the right corner, this bracket on the right corner, and I do a mouse click of that so that bracket's selected. And I'm going to do Control C to copy what I've typed in there. And now I'm going to type Control V to paste it. And I'm going to show you how different things look when you take control of the range of what you're viewing. So this is the Y window. And all I need to do, and notice how in order to use this, the P and the R have to be capitalized. And then to get this arrow, I really just typed the dash, which is next to the 0 on the main keyboard, and then shift where the period is. Or another way that I could get this is to start typing and plot range shows up. And then the arrow comes in automatically if I do that. Now, because I want to be in control, I'm going to type a pair of braces, and you have to use braces here. If you use a parenthesis or a bracket, you're going to get an error message. It's not going to know what you're talking about. So you have to use braces. This is a computer program, and it has been programmed very specifically. So I'm going to give it a smallest y value and a largest y value. So I'm going to go from minus 50 to 100. And I'm going to see what that does. Okay, so that looks really strange. But what that's telling me is that there is some information. Now that I'm more zoomed in, now I'm too close to see the important information. Here, I'm too far. My y is going from 0 to 500,000, and as I zoomed in closer, now my y is going from negative 50 to 100. I see that I'm too close to see all of the information, but I do see there's a lot more happening than I thought. And what I can see is that this is telling me in quadrant 2 there's actually a peak, a mountain peak, and in quadrant 4 there's actually a valley peak. And I'm not seeing that completely because I'm too close. Here I'm not seeing it because I'm too far away. So I'm going to increase my negative y value, and I'm going to try negative 200, and I'm going to increase my positive y value to 1,000. And I'm going to see if that makes a difference. Oh, okay, so I see that I almost got it. I'm still a little too close to see completely the top of this mountain peak in quadrant 2. I'm still a little too close to see completely the bottom of the peak in quadrant 4. But I'm actually a lot better than I was previously. So I'm going to type in, and I can see that I don't need to go too far. I'm going to just type in negative 220, and here I'm going to type in positive 1200, and I can see that I'm almost there, so I'm pretty close. And I'm going to hold shift and push enter. And now I see that's a really good range on y to go from 0 to 1200. And I actually could even narrow my range in the y direction, because I see that if I went from like negative 6 to even positive 5, that's going to kind of spread it out a little bit, and that allows me to better view things. So I need to narrow the window on x, and I also needed to narrow the window on y. And so notice you can't even see all of this in the very basic fundamental use of the plot function. You can't see that all of this is happening because you're too zoomed out. If you zoom in too close, you don't see what you need to see either. So you'll have to kind of play around with your x and your y values to see things more clearly. But here you see your x-intercepts very clearly. They look like they're, and obviously we know what they are. We know they're -4, 3, and 0. And we see those here. And notice that since the factor that gives us -4 as a 0 is raised to an even power, we know the graph is only going to touch at that 0 and not cross. The factor that gave us 0 as a 0 is x, and that's raised to an odd power. So we know the graph is going to cross the x-axis at that 0. And then the factor that gives us 3 as a 0 is raised to an odd power. So we know that the graph is going to cross at that 0. And we see that that's exactly what it does. So these are some of the things you have to consider as you use the plot function. And what's nice about this, you can print these out. Some other features that you can use, I want to just kind of contrast and show you those that you may find very helpful, especially if you're planning on printing something, is to use the plot style. And typically if you just use one feature, you can just type that feature in. So you can type in a color, you can say I want this to be dashed, you can say I want it to be thick. And I think for printing, to select thick is a really good choice. And you could type in other colors. You could have used black, gray came up as a choice, or blue or red. And so let's hold shift and push enter, and notice how the graph is now thicker than it was previously. And then you can do things like, if you want to give more directives, you can say dashed, thick, I forgot, let's change colors, let's say green. So if you're going to give it more than one instruction, they have to be given as a set. And that's why you use the braces. And so notice how that changed. Okay, so that's how you can use the plot function. The only other thing I want to show you before we close this out is that you can use plot and enter more than one function. So that's what the second option is. And so it's letting you know you can enter 2 or more functions, but they have to come as a set. And so, let's say, for instance, I wanted to enter, since we're working on the rational functions, let's say I wanted to enter the rational function 6x squared over, and so since I only have a single term in my numerator, I don't need to parenthesize it. If I'm using this diagonal fraction bar, I do have to parenthesize the numerator and or the denominator if I'm using more than one term in the numerator or denominator. Let me make this 3x squared minus 3. All right, so the other function I'm going to enter is the function, so this is the function y equals 6x squared over the difference 3x squared minus 3. Here I want to enter 2 because that's actually my horizontal asymptote. And so I'm going to let x range from, let's do, I kind of do negative 10 to 10 as a foundational or basic range of values of x. All right, and so notice how this comes up. The actual graph is here, and again, notice I've got this issue where I'm not seeing this middle branch completely. Okay, actually these are yeah, so in other words, I need to really change my settings here for y. So let's say plot range. Let's go from negative 10 to 10. And notice now I can actually see that, and that's kind of unusual for Mathematica to do that, but sometimes it doesn't give you the best view. So notice I wasn't seeing this middle branch. These two vertical lines are actually my asymptotes. They're not actually part of the function. They're asymptotes, and usually in rational functions, Mathematica always gives you the asymptotes. And so you just need to keep that in mind, that these are asymptotes, and I can use graphics, drawing tools to go in and make those dashed. So I just select them. And you know, if it's confusing you to see those and it seems like those are part of the function, then it may help to go in here and dash them so that you know that they're not. And sometimes you have to click out to, all right, and I'm going to also dash that asymptote as well. Oops. Right. So drawing, if you go to graphics and select drawing tools, this palette opens up, and you have various things you can do with this palette. But this allows me to dash the asymptotes. All right, so we'll stop here. And I hope that you enjoy using this. It's a wonderful, wonderful program. I actually used it for my graduate research when I was in graduate school. So very easy to use, very specific though. You have to use it as it was designed to be used or it won't work. But I think you'll find it very helpful as you work on Chapter 3 material.